Hi, and welcome to today's episode of the Oxford Centre for Personalised Medicine Flash Interview Series, where we discuss different aspects of personalised medicine with people involved in the field in one way or another. Today's guest is Dr. Alex Martin-Geary from the Wellcome Centre for Human Genomics at the University of Oxford. Hi, Alex, it's great to see you. So let's just start off with you telling us a bit more about yourself and where you've come from.
So I'm a bit left field when it comes to the world of genetics, and I actually came here through archaeological sciences. So I did my undergraduate degree in York when I think I graduated when I was 30. So I'd been a barmaid for years and years and years and done various other jobs for a very long time, and then came to academia quite late. And while I was doing my undergraduate degree, I absolutely fell in love with genetics, and it was my final year of my undergrad. Was the first time that I heard the word bioinformatics, which just sounded magical and wonderful, and absolutely fell in love with it. So I went to Manchester and did a master's and PhD in bioinformatics with a special focus on evolution, and then started at the Wellcome Centre in October last year. So I've just completed my first year here, and absolutely adore it. Love it.
Brilliant. So if I say personalised medicine to you, what comes to mind? And how does your current work tie in with the main aims and themes of personalised medicine?
So I'm currently a postdoctoral bioinformatician in the computational rare disease genomics group. So personalised and rare kind of go really hand in hand. And there's a big movement recognised at the moment, instances which they call N=1, which means that rather than having a large cohort of patients that all suffer from the same thing and you can sort of pool information on, there's a lot of rare diseases where there's only one person that suffers from it, which is, it makes things very, very complicated to try and identify and help them. So identify the causes and help them. But switching it on its head, if you actually take all rare disease as a group, then you find that actually that becomes quite the opposite. So there was a thing in the news yesterday. So a paper has just been released by the 100,000 Genomes Project Consortium, and they highlighted the fact that rare disease isn't as rare as people assume. And in fact, there are roughly 3 million people in the UK who suffer from a rare disease, which is 6% of the population. Or if you take it a different way, that's 1 in 17 people that you can meet actually suffers from a rare disease. And it's incredibly important for their lives and their families to understand what is wrong and actually try and gain some sort of help for that. And so what we do is we try to provide them some information and whatever we can using genetic sequences to try and help with that.
Lovely. So you mentioned the 100,000 Genomes Project. Could you tell us a little bit more about what that actually is?
Yeah, it's fantastic. It's absolutely fantastic. So the 100,000 Genomes Project was conceived as an idea a few years ago and gained funding in the UK. And the aim was to get 100,000 genomes of people with rare diseases and or cancers, so that we could actually combine this information and make it more likely that we would be able to provide diagnoses for rare disease patients, because they often go for years with what we refer to as a diagnosis odyssey, which is from pillar to post to try and find somebody who can help them. Now, the 100,000 Genomes Project has been fantastic in terms of increasing the diagnosis rate and diagnosing people who had literally spent years without any sort of information. Obviously, it's still not obviously, we can't say 100% of people, pop, bam, we've got your diagnosis, but it's definitely making a difference. It's also inspired more programs of its kind to be developed around the world, and through very strong collaborations we're able to actually identify, when we thought n equals 1, there's actually different people in different countries who also suffer from various diseases that can be identified through this, and not the individuals obviously, but the causal variants can be detected that way, or we can start thinking about them that way, which has been phenomenal.
Fantastic. So could you give any specific examples where data available in the 100,000 Genomes project has directly benefited the lives of families recruited to the project?
So I personally haven't fed back any of my work to families yet, because we have to be absolutely sure. So it can still take quite a long time between identifying something that could be causal and actually reporting it back, because we need to be absolutely sure. However, as I was saying, there was an article published yesterday, and alongside that were some stories which I will share of patients who have had a direct response. And there's one which absolutely choked me up, because it's a sort of bittersweet story about a little boy who had a rare disease, and he sadly passed away, but he was enrolled in the 100,000 Genomes project by his parents, and they were able to identify that he had a vitamin B12 uptake issue, and because of being able to understand that, it meant that his younger brother has actually been able to receive treatment to prevent the progression of his disease as well, which is incredible. It's wonderful. It's saving this little boy's life currently, and there are, that's just one story. There are dozens and dozens that are similar.
Wonderful. So obviously there's a lot of really positive outcomes from this project, but I imagine there are some disadvantages, challenges, points of contention as well.
Yes, so it's a very, very large data set to use. So from a bioinformatician's point of view, that can be difficult to interact with. And that is compounded by the fact that because of data security issues, everything has to be done in a very, very specific and very secure way. On the flip side of that, the data security is amazing, and that is absolutely essential, and I'm all for it. But one of the things that has, again, there's positives and negatives to it. One of the things that has happened over the last year since I've been using it quite heavily has been that there's been a massive increase of data added to the environment, which is phenomenal. So the expansion of the somatic data set, so the data set relating to cancers, and also COVID-19 research has meant that there are huge amounts of data now that people can work with, but it also means that it wasn't really built for that initially, and so it can be quite challenging at times because there's quite a high demand. There are ways to work around this, and the people who work for Genomics England and manage the research environment are absolutely incredible. They go out of their way to constantly make improvements and to help researchers, and it's phenomenal. And we just need more funding for them. I think we need more of this to actually allow it to handle the level of researchers that actually require access, I think.
Great. So finally then, as a user of the 100,000 Genomes data, as a researcher, how much more do you think that we still have to learn from the data that's available?
Absolutely masses. Huge amounts. So one of the things, well, our research group's main focus is on near coding genetics. So if you're not 100% what that is, it's the sections sort of directly up and downstream of the bits of genes that make proteins, and they haven't been terribly well studied historically, because their impact isn't necessarily as obviously known as if you have a protein coding change. And so there's an awful lot that we don't know about just those areas specifically, but then also huge other swathes of the genome. So there's a lot going on that we genuinely don't know anything about currently. And so that's going to take time to sort of tease out what could be happening in those areas. I know there was the anecdote that the chap in oh gosh, what was it? There was an anecdote a few years ago about a guy who was quite senior in one of the government institutions, the patenting office, I think, that said, oh yes, there's nothing else to be invented now. Everything's been invented. We can stop patenting things. And there's always the desire to be able to say, we've learned everything that we can know about an aspect. But I think as scientists, we'll never, ever be able to say that. Ever, because there's always more to know and there's always more to find out, and we've just got to take the baby steps, and projects such as the 100,000 Genomes project are the way that we can actually start learning, I think.
Great, thank you so much for your time. Do you have any other things that you want to say before we finish?
No, I think we've covered most of the 100,000 stuff.
Lovely, thank you very much.